All right, everybody, welcome back. We are going to look at transforming data today, and specifically, we're going to look at what happens to both the mean and the standard deviation whenever we change these values. So I've got a sample of quiz scores. So we have a student that scored a 68, a student that scored a 71, and also a student that scored a 77. So on the calculating device, you can put these three values into a list like I did. So I've got my three scores, and then go back to calculate, and we're doing one variable statistics. So I'll hit enter. I'm just trying to get the mean and the sample standard deviation right now. So we've got a mean of 72 and a standard deviation of 4.58. So again, our mean is 72. The average student scored a 72. And the standard deviation is 4.58. 4.58. All right, so our scenario here is a teacher gets these scores and they want to alter them. Maybe it's a generous teacher and he's trying to give the students some more credit. So our first example here is called just example number one. He wants to give them a curve, like a scaled score, and he is going to add, he's going to add 10 points. He's going to add 10 points to each score. He's going to add 10 points to each score. So what's that going to do is make the data look like this. So instead of 68, 71, and 77, we're going to have a 78, an 81, and an 87. I don't know why I made these curly brackets so big. So anyways, for this new data set, we're going to calculate the mean and the standard deviation. And we just want to know, how do they change? What changed and by how much? So let's go back to the calculator. And if I go back to stat, I'll go to edit. And so if you scroll to list 2, and it's asking you what do you want list 2 to be equal to, hit enter. And then if you hit second, and then way down here at the bottom, if you hit 1, it'll reference L1. All right, so this list is going to be equal to everything here, but let's add 10 to it. And then hit enter, and everything will populate for you. So we've got all our scores, 78, 81, 87. Now I'll go to stat, I'll go to calculate, one variable statistics, and I'm not gonna pull the data from list 1 this time. I've transformed that data, and I put our new data into list number 2. So I'll put list 2, calculate, and let's jot down the mean, X bar, and the standard deviation. And we're just using SX rather than this symbol for now. So the mean now is 82, and the standard deviation is still approximately 4.58. So when you take a look at these two values, or these two groups, these two data sets, after I transformed the data and added 10 points to each score, the mean increased by exactly 10 points. The standard deviation, however, was not affected at all. And this should really make sense. We're looking at distances to the mean for the sample standard deviation. Now the distance to the mean for like the 68, the distance from 68 to 72, well, that's a difference of 4. If I go down here, 78 to 82, that difference is also 4. So that is a very key point that we need to make here. I'll put a star. Adding or subtracting, adding or subtracting, adding or subtracting constant amounts, adding or subtracting constant amounts changes, what does it change? It changes the mean, changes the average, not the standard deviation. Not the standard deviation. All right. So again, like if you had the opposite of a generous teacher and you had like a really big, like not so nice person, and they took 10 points away, the same thing would have happened. If I would have taken 10 points away from each score, the mean would have dropped to 62, but the standard deviation would still be 4.58. Okay, on to the next thing here. Let's do example 2. Example number 2. I'll put a 1 up there. So instead of just adding or subtracting a constant amount, maybe we're needing to like convert units. So like going from inches to feet, or like kilograms to pounds or something. You're transforming every single data point, but we're just going to stick with this kind of same scenario with the quiz score. So instead of adding 10 points to each score, let's have the generous teacher curve the scores. This guy, he's going to curve scores. He's going to curve scores by a factor of 1.2. So what this would do, if he's multiplying the scores by 1.2, it's essentially helping the students that did better. So like the kid that got a 77 is going to get more curved points than a student that got a 68. So let's calculate the new data. Let's calculate the new data. We'll do it in the calculator as well. So if we go back to the calculator, let me go to stat, over to calculate. We'll do one variable. No, let's actually make the list first. So we're going to change this then. We don't want to just add 10 points. So let's go back and hit enter. So list 2 equals, it's asking you what you want to put in. Now for multiplying, let's do our 1.2 times list number 1, like that. So list 2, we're going to change all those values. It's going to be 1.2 times the original scores. And if we hit enter, there we go. So we've got 81.6, 81.6. We've also got 85.2. And we've got 92.4. So for this data set, let's see what happened to both the mean and the sample standard deviation. All right, so really easy to find these on a calculator. Please use a calculator, not like make a table or anything. So one variable statistics, I put these scores into list 2, so we're good to go. It calculates. And all right, so we have a new mean. It is 86.4. 86.4. 86.4 is the average score using this method. We're also looking at the sample standard deviation. That rounds out to pretty close to 5.5. So we'll go with 5.50 maybe. 5.50. All right, so take a look and try to relate these values to the statistics that we calculated from the original data set. It's pretty interesting, I think. If I take the mean there of 72 and multiply it by the factor, I get 86.4. Now, standard deviation might not be exact because I was rounding, but if I do 4.58, my original standard deviation, multiply by the scale factor of 1.2, I get something pretty close to 5.50. If I were just to round up to 6, round up to 9, So yeah, hey, if we multiply, divide, multiplying, or dividing changes both the mean and the standard deviation. Multiplying or dividing, it changes both values. All right, so now we're going to do one more example, and I'll just wrap this thing up. So example number 3. Example number 3. So this is like a linear transformation. So we have this other teacher who wants to give a solid 5 points to each score, and also help out the students that did better by using a scale factor. All right, so this third teacher, he is going to curve, our original score. He's going to curve by a factor of 1.2 and add 5 points to each score. 5 points to each score. Curved by a factor of 1.2 and add 5 points to each score. So let's get the new data set. Doing quite a bit this time. And I'll just do it on a calculator rather than having to do it to each individual data point. So I'll go to stats, I'll go to edit, scroll up to list number 2, hit enter, and here's where my formula is going to go. Now we're going to follow order of operations. We want to do 1.2. We want to do 1.2 times every original data value, every data point here. So I'm doing 1.2 times list number 1, and then I'll add 5 points to each score. Hit enter, and here's what we get. So essentially all we've done is taken these values and added 5. So anyhow, it's going to be 86.6. We have another score of 90.2. And our last score, the student that did the best, is now going to receive a 97.4. Very, very generous. All right. So for these statistics here, it might even be a good practice thinking about which one of these affects the mean and the standard deviation, or both, or I guess even either. So the x-bar, it gets changed, right? If I kind of look at these keys here, it gets changed by adding constant amounts and also by multiplying and dividing by a factor. I should have said a constant factor. We want to multiply each value by exactly 1.2. But anyhow, the new x-bar, we know that, well, right here, we multiplied our original mean by 1.2 and got 86.4. Adding 5 points to each score then will just increase the mean to 91.4. We'll test this out on our calculator. That is not written correctly, 91.4. The sample standard deviation, remember, from this sample standard deviation here, if I then add constant points or a constant value, add or subtract a constant value, not going to change the sample standard deviation whatsoever. So our sample standard deviation for this should be pretty close to 5.50. All right, so let's test this again on our calculator. We already have the data in, so let's go to stats, calculate. We're doing one variable statistics in list number 2. And so let's compare our values. We've got x-bar at 91.4 and a sample deviation of 5.499, or something pretty close to 5.50. Awesome. So this is known as a linear transformation. And so if we do both, if you multiply and add or subtract, the mean changes by both of those values. The mean changed by the factor of 1.2 and by adding 5 points. The standard deviation, though, only changed by the factor of 1.2. All right, so I've got some example problems that I'm stealing from the internet. Let me go here, and I'll just try a couple problems with you. So just in Khan Academy, guests at a picnic try to guess the number of candies in a jar. The distribution of guesses has a mean of 85 and a standard deviation of 12 candies. Suppose the jar actually holds 105 candies, and we want to convert each guess to its error. So that's the transformation taking place. That is, we'll subtract 105 from each guess to see how far above or how far below the guess was from the correct number. What will be the mean and standard deviation of the distribution of errors? Okay, so if we think about what happened, all they're doing is subtracting a constant amount. So that tells you something right off the bat. The standard deviation is not going to change. So we only have two plausible solutions. It would either be this or this, because they both have standard deviations of 12. So they're subtracting 105 from 85. So like essentially that x bar of 85, you're subtracting 105, which gives you a mean of negative 20 candies. Awesome. So let's move on to the next one. Hopefully it's both. Distribution of raw scores on a particular achievement test has a mean of 500 and a standard deviation of 80. If each score is increased by 25, what will be the mean and standard deviation of the new scores? Okay, so again, we are just increasing or adding by 25. So the standard deviation is going to be unchanged. The standard deviation is going to stay at 80, but the mean will increase by that amount. The mean will increase by 25. So we're doing 525 for the mean and 80 for the standard deviation. I'll do one more. Cargo loads that Niels transports in his truck have a mean weight of 42,000 pounds with a standard deviation of 1,500 pounds. What will be the mean and standard deviation of the distribution of weights in kilograms? 1 pound is approximately 0.45 kilograms. So this time we are going to be multiplying. You are taking the value in pounds and multiplying it by 0.45 to convert that value, or to convert the unit to kilograms from pounds. So since we're multiplying this time, we're multiplying to convert units, both statistics are going to change. Both the mean and standard deviation are going to change. And multiplying by 0.45, so like that essentially cuts them in half, a little bit less than half of this. So anyways, the mean would be 18,900 kilograms, and the standard deviation is going to drop to 675 kilograms. So we'll check that. Okay, so I'll put this on my Schoology page. You can practice this on your own, but hey, that's going to do it for this video, guys. Thanks for watching. Bye-bye.